Dear students, we are continuing the chapter number 16 for grade 12 and we are talking about the isomerism. In the last lecture we done the chain isomerism. Then we done position isomerism. Now we have to do functional group isomerism. Lecture number 31, 37 and grade 12, and we are doing isomerisms and their types. So there are two main types of isomerisms. One is called stereoisomerism and another is called structural isomerism. So we are talking about only first structural isomerism. So structural isomerism has more 6 isomerism, and first we done chain isomerism, then we done position isomerism. Now we are going to do functional group isomerism. Dear students, in the functional group isomerism, the organic compounds having the same molecular formula, but different functional group. When the functional group is different, means all physical and chemical properties of organic compounds are going to be different, but the molecular formula is same. So examples are given here: acetone, organic compounds having different functional groups, but molecular formula is same. But molecular formula is same. These are called functional group isomerism. So examples are given here: propanol, acetone or propanol, and you are seeing carbon 3, hydrogen 6, oxygen 1, C3H6O, another compound would be different. This is the propanol aldehyde. This is the ketone group and this is the aldehyde group. So you are seeing that 1, 2, 3 carbon atoms, 3 plus 2, 5, 1, 2, 6 hydrogen atoms, and there is the one oxygen. So both have the same molecular formula, but functional groups are different. So these types of the organic compounds are called functional group isomerism. Functional group isomerism, same molecular formula but different functional groups. So this is a propyl aldehyde and also acetone. There is another one, acetic acid. This acetic acid, ethanoic acid, one, two carbon, 3, 1, 4 hydrogen atoms, 2 carbon, 3, 4, and there are 2 oxygens. And there is another one. This is the CH3. I'm going to change this. Methyl formate. This is the methyl group and this is the formate. H C O N. This is the formic acid. Methanoic acid, formic acid. So when I remove this H, this is called formate. This is a formate, methanoate, and then alkyl group. This is the methyl formate. Methyl formate. So both have the same 2 carbon atoms, 3 and 1, 4 hydrogen atoms, and there are 2 oxygen atoms. So these are called functional group isomerism. And maybe other also. One, 2 carbon, 1, 2 carbon, 3 and 3 hydrogen, 3, 2, 5, 1, 6 hydrogens, and 1 oxygen, and there is also 1 oxygen. This compound is called dimethyl ether. Dimethyl ether, and this compound is called ethanol. So students, all these compounds have different functional groups, but the molecular formula is same. When the molecular formula is same, functional group different, their chemical physical properties are totally different from each other. Their physical and chemical properties depend upon the functional group. So this is called functional group isomerism. And number 4 is metamerism. Metamerism. Students, this type of organic compounds having the same molecular formula and also same functional group. Same molecular formula, same functional group, but with the functional group different carbon chain. On the other side, both sides, you will find different carbon chain. Is called metamerism. I'm going to write example, then you will understand. This is the CH3, and this is the CH2. Ether functional group, CH2 and CH3. Now I am going to change this. If you see very well, these two compounds, both ether are functional group same. On their both sides, two carbon each symmetrical. This is symmetrical ether, diethyl ether. Diethyl ether. This is a diethyl. Two carbons on the left side and two carbons on the right side, symmetrical. Diethyl, but in this case, you are finding one carbon is on the left side and three carbon atoms on the right side, but number are same. Number of the carbon atoms are same. So this is a methyl and propyl ether. Methyl and propyl ether. Methyl and propyl ether. This is a diethyl ether. Functional group is same. Number of carbon atoms are same. Number of hydrogen atoms are same, but on both sides, either sides, with the functional group, number of carbon atoms are different attached with the functional group. This type of the isomerism is called metamerism. This type of isomerism due to the unequal distribution of number of carbon atoms. 2 same, 1 3. Unequal distribution of the carbon atoms on other side of the functional group. So these are the homologous series, and there is also other example you have. This compound is called 1, 2, 3, 4, 5. 2 butanone. 2-butanone. Pentanone, 1, 2, 3, 4, 5. Now this is 1, 2, 3, 4, 5. This is 3 pentanone. So on the left and right side of the carbon atom, either side, you are finding unequal distribution of carbon atoms. Different carbon atoms are going to be attached. These examples are for the metamerism. So metamerism is a type of isomerism due to the unequal distribution of carbon atoms on either side of the functional group. Examples I have given. Last number is tautomerism. In the tautomerism, a type of isomerism in which the compound exists simultaneously in the two form in equilibrium. the type of isomerism in which compound exists simultaneously in the two forms in equilibrium with one another is called tautomerism. So example is given here. I am going to write first example. So this is the CH3 ketone functional group. There is a CH2 this one is called keto form. Exists in equilibrium CH3 OH double bond CH COO C2 H5. This is called enol form. Enol form. So here you are seeing that this carbon is ketone group. Here the ketone and here same. So what happens in the other side? You are seeing that one hydrogen from this carbon shifted to oxygen there to make OH group. And the valency of this carbon and this carbon is not going to be satisfied. So double bond is going to be attached with the two carbon atom to satisfy the valency of carbon, this carbon as well as this carbon. So they are existing in the equilibrium. They form equilibrium. So this type of the isomerism is called tautomerism. This is the ketone group, that's why we call it keto form. This is the alcohol group, we call enol form. So I am repeating again. A type of isomerism in which compound exists simultaneously in two forms in equilibrium with another. It involves the shifting of position of the proton. Shifting of position of the proton. So here is a proton. So it shifted. This proton is shifted here with oxygen. You are seeing double bond here, and this double bond is shifted here. This double bond is shifted here, and this hydrogen is going to be shifted here. You will get enol forms. It involves the shifting of position of the proton. This type of hydrogen atom is known as this hydrogen is called mobile hydrogen. Because it is moving from one carbon to other oxygen atom. So it is called a mobile hydrogen, or we call it moving hydrogen. So this is called a tautomerism. So students, we done all 5 kinds of the structural isomerisms. Structural isomerism, geometric isomerism we will do here. Then you students go back again. Isomerisms, 2 isomerisms, stereoisomerism and structural isomerism. Stereoisomerism has 2 types: geometrical isomerism, cis-Fluence isomerism, and optical isomerism. So we have to do now. Then structural isomerism has 5 types, and I explained all the 5 types here. Now they are chain isomerism, position isomerism, functional isomerism, metamerism, and tautomerism. We done all these one now. Before we start the stereoisomerism, there are very important terms we have to explain. So these chiral center. Chiral center. Before we explain the stereoisomerism, cis-trans isomerism or optical isomerism, there are some important terms we have to explain. Number one is called chiral center. So chirality is a property present in an object that cannot be superimposed on its mirror image. Cannot be superimposed on mirror image. Chirality is a property present in an object that cannot be superimposed on its mirror image is called chirality. Chiral objects or chiral molecules do not have plane of symmetry. Do not have plane of symmetry. Not a plane of symmetry. Do not have a plane of symmetry. These are called chiral objects. Chirality is typically seen in a molecule that have a chiral, or in other words we call chiral or asymmetric carbon. Asymmetric carbon. Asymmetric carbon atom. Just like you are seeing your hand, if you see in the mirror, so this left hand is the same as the right hand, but this left hand is not going to be seen the same in the mirror. So these are called asymmetric, dissymmetric objects, asymmetric objects, dissymmetric or asymmetric. So I told you the chirality of object typically seen in the molecule that have a chiral or asymmetric, dissymmetric carbon atom. We have many examples. The dissymmetric or asymmetric carbon atom cannot be superimposed on its mirror image. Means your left hand, for example, does not possess the plane of symmetry. It will, if you see in the mirror, your left hand will be same as the right hand. Not the same. This is not going to be superimposed. A left hand, for example, does not possess a plane of symmetry, and its mirror image is not an other left hand, but it is same as a right hand. So you can see in the diagram, page number 129, your left hand, if you put in the mirror, you will see it is the same as right hand. You will find like this. This is the left hand. Put your on the mirror. you will see like this. Like this you will see. So it will be not similar as an other left hand, but it is similar to your right hand. This is called chiral center, chiral molecule, asymmetric, dissymmetric. The two are not identical because they cannot be superimposed. If we were lay one hand on the top, on other fingers, the thumb will clash. You can see in the diagram, the thumb will clash. These are called chiral. The mirror image relationship of the left hand, notice that right hand is a mirror image of the left hand. The right hand is a mirror image of left hand. So an object lacking of plane of symmetry, is called dissymmetric or chiral, pronounced K-I-R-A-L. Chiral. So a symmetric object is referred to as achiral, which has a symmetry is called achiral. Which has a symmetry. Suppose this is a board and I am going to cut this, you will see the same halves. So these are called achiral. One table and you want to cut middle, you will find the same two halves. Head, and if you make a line between the head, you will see the same half. If there is a human being, if you make a line between the human being, same halves. So these are called achiral, symmetry. They have a symmetry. A person's hand, gloves, lack of the symmetry. They are called asymmetry. Gloves, and they are not superimposed with each other, but the table, the board, whiteboard, you will find the same of symmetry. Human being, head. So these are called asymmetric. They have a plane of symmetry. A dissymmetric object cannot be superimposed on the mirror image. I gave example, the left hand is going to be showing the right hand, not another left hand. So this is a very important and you must clear it. What is the difference between chiral and achiral? A is capital A with a C. Chiral objects cannot be superimposed on its mirror image. Do not have a plane of symmetry. But achiral molecules, they have the plane of symmetry. Already I give you the examples so you can differentiate both. Many examples are given in your book. Your hand, your foot, your shoe, your ear, they are chiral molecules. They are like dissymmetric molecules. They have no plane of symmetry. But my glasses are symmetrical. If I cut from here, you will see the two similar halves of my glasses. They have symmetry. So are called achiral objects. Table, chair, fork, glass, eyeglasses. These have the plane of symmetry, are called superimposable on their mirror images. But chiral molecules at least one an asymmetric center, dissymmetric center. They do not have a plane of symmetry and not superimposable on their mirror images are called chiral objects. So I think it is very clear for you. Now here the actual, we are talking about the organic chemistry, the stereochemistry. This is a branch of chemistry which we are dealing with. Stereochemistry, carbon-based chiral centers now. Carbon-based chiral centers. Carbon-based chiral centers. For instance, we have examples here. A carbon atom which is bonded 4 different groups, asymmetric. 4 different groups and asymmetric carbon atom. These are called chiral. This asymmetric, symmetric carbon. This is a carbon, and on right here, this is a carbon center. On the top, ethyl group. Left, methyl group. Bottom, halogen bromine group. Right, and propyl group. Like this one. This center carbon attach all different groups. 1 carbon, 2 carbon, 3 carbon, functional group halogen. And if you want to give the name of this compound, select longest carbon till 1, 2, 3, 4, 5, 6 carbon. Longest 1, 2, 3, 4, 5. So here 1, 2, 3, 4, 5, 6. So the name of this compound is 3-bromo alphabetical. 3-bromo, 3-methyl, 3-bromo, 3-methyl hexane. So 3-bromo, 3-methyl hexane is an asymmetric, dissymmetric carbon, asymmetric carbon, dissymmetric carbon. Around the central carbon, all the 4 groups are different. A carbon atom which is bonded to 4 different groups is called asymmetric. Asymmetric carbon. This carbon is an asymmetric carbon. Asymmetric carbon. And the example is given also, I will write here. Carbon center up, C, OH, hydrogen, OH, and CH2OH. So instead this carbon is also asymmetric. You are seeing on the top carboxylic acid. Carboxylic acid functional group on the top. Down alcohol group, CH2OH, CH2. First there is a carbon, carbon atom and then functional group. This OH direct atom, this carbon right side, left side hydrogen. So this carbon is again asymmetric. This is the carboxylic acid. Now, if you give the name 1, 2, 3. From this carbon start, carboxylic acid very reactive. It will start from here. Indirectly attach this OH. So carbon chain is a 1, 2, and 3. And you will have 2, 3 di hydroxy, 2, 3 dihydroxy, propanoic acid. Propanoic acid. So dear students, this is the a chiral or dissymmetric. The term asymmetric carbon atom is rather misleading. It only means the carbon atom is bonded to the 4 different groups and the molecule of this type lacks plane of symmetry. Such molecule is called asymmetric, Latin word without symmetry. That's without symmetry. Presently the term dissymmetric or parallel molecule is often for the asymmetric molecule. So we use dissymmetric or chiral molecules with the asymmetric molecule. So dear students, we done this inshallah next time. Next lecture we will talk about the optical activity. So here we are going to stop here. Thank you very much.